Greetings. Today we are going to simulate a 5 GHz patch antenna. The procedure remains similar as the previous video before. Go to antenna, select planar, time domain, make sure the units are same. Now since we are simulating a 5 GHz antenna, we choose the range as 3 to 7 and select all the E field, H field, far field monitors. Now we quickly press on finish, and before proceeding ahead, make sure that you save your file. So we'll be naming our file as patch_5 GHz. So the parameters and the formulas along with the derivations and the reasonings all have been uploaded in the description below. So you can verify them and use those same formulas if you're simulating for another frequency. Now quickly we go to modeling. We select a block, escape and substrate. This will be our middle layer. We put the dimensions as x minimum is from -a/2 to +a/2, y minimum -b/2 to +b/2, z minimum -h/2 to +h/2. We put the material as FR4 lossy. So for that, we go to material, load new material from library. We search for FR-4 and we select the lossy material. Click on load. Once we are done with that, we click on preview and we put in the parameters of A, B and H. Now this standard values for substrate and ground, you can use it for any antenna because your resonant frequency and directivity along with bandwidth are mostly dependent on the patch dimensions. So A is 40 mm, B is 30 mm and H is 1.6 mm. Press on OK. Now we have a substrate. Again press on block. This will be a ground term layer. X goes from -a/2 to a/2, Y from -b/2 to b/2, but Z goes from -h/2 to -h/2 minus T. Also the material that we use from now onwards for ground and patch will be copper annealed, which is a lossy material. So load new material from material library. We select on copper, the first option, annealed, which is lossy metal. Once we're done with that, we click on preview and put T as 18 micrometer or 0.018 millimeters. Once we're done with that, press on OK. Here we have our substrate and ground. Now we click on block again. This will be our patch_rectangle because we are simulating for a rectangular patch antenna. Now in this patch antenna, remember that we have a coaxial feed line. So we'll be studying microstrip line later. So these are the x and y ranges, -x/2 to x/2, -y/2 to y/2. H is from h/2 to h/2 plus T. The material remains copper anneal lossy, h/2 plus T. Preview. X values will be, I'll show you the values that I have used in a prior simulation of the same antenna. So you could directly copy these values or use the formulas to derive your own. So these values I've gotten by trial and error. So x 13.77, y 8.2. So by using these values, I got a resonant frequency of 5 GHz and my required bandwidth as well as return losses. So I'll explain later what to tweak if you don't. Simply click on preview, OK. Now we move on to making the coaxial feed line. Simply click on cylinder, hole. The outer radius will be 3.3/2 to 0. X center, this will be x/8. So x is our length. So we choose x/8, that is from the center a distance of x/8. Z minimum from -h/2 minus T to h/2 plus T. Simply click on preview. So we have from the center at a distance of x/8 with a radius of 3.3/2 a hole. Now click on that hole, ground, and subtract the hole, ground minus hole, and enter. So you can see that we have a region to insert our inner conductor. Now again cylinder, inner conductor, the outer radius this time will be 0.5 millimeters, x center will be x/8, You simply can choose any value that ranges from the length by 4 to length by 6. Now the length is x, and we've used x by 2 on one side and minus x by 2 on the other side. So I'm using length by 4, so I'm getting x by 8. So z minimum is h by 2 plus t and minus h by 2 minus t minus 2. So this is my inner conductor. I simply press on inner conductor plus patch rectangle. So in order to basically connect the inner conductor with the patch, that's basically making a joint. Now we move on to making the dielectric. For the dielectric, we again choose cylinder. This time the outer radius will be 3.3 by 2 minus t all the way to 0.5. X by 8 will be the center, z minimum from minus h by 2 to minus h by 2 minus t minus 2. Now material will be FR4 lossy. Keep that in mind that dielectric is something that is between the inner and outer conductor. So once we are done with that, simply click on preview. Okay. Now the mistake that I did was, instead of choosing FR4 as the component material for dielectric, I had not changed it from copper annealed. So I'll do it all over again. Outer radius 3.3 by 2 minus t, inner radius 0.5, x center x by 8, z minimum from minus h by 2 to minus h by 2 minus t minus 2. Make sure you change the material from copper annealed to FR4 lossy. Once you're done with that, simply click on preview, and yeah, you're done with the dielectric. Now we move on to making the outer conductor cylinder again. So the outer conductor will have specs something like the outer radius is 3.3 by 2 and inner radius is 3.3 by 2 minus t. X center is x by 8, z minimum maximum minus h by 2 and minus h by 2 minus t minus 2. Material, change it to copper annealed. Preview. Okay. Now you have to combine the outer conductor with ground. Simply click on outer conductor, shift plus and the ground, and there you have connected that as well. Now always remember to press Ctrl save. Now go to picks and pick edge and pick the edge of the outer conductor, and we go to simulation waveguide port. Remember that the direction of the arrow must be towards the patch. Now apply, and there you are done with your 5 GHz patch antenna. Simply click on start simulation, and once you are done with that, we'll observe the 1D parameters, that is the S11 parameters. You can see that we have a resonance of 5 GHz at a gain of 27 to 28 dB. Now we simply calculate the bandwidth. For that, you show measure lines minus 10 dB, and then you bring the other two frequency lines so as to intersect with the 10 dB line and the curve. So formula is 2D divided by F1 plus F2. D is given and F1 and F2 are 4.9. So here we have our bandwidth as around 3.6-3.8%, which is pretty good. Resonance at 4.996 GHz and return losses minus 29 dB. And we have a good directivity of 6.3 dBi, which is excellent for a 5 GHz patch antenna. Thank you for watching.